Alright, so I wanted to look at number 4, um, and just to get warmed up I'm going to revisit number 3. We did that in class, but just to remind ourselves all the things we know about regular polygons, even if all you have is that the central angle is 30 degrees, you still know it's a regular polygon. And that means it has a center because it can be inscribed in a circle. So I guess the real problem I have with number 3 is, I don't know how many sides it has. It says it's a regular polygon, but to me it's just an n-gon because I don't know how many sides it has. But we can find out, because if you know that the central angle is 30 degrees, and you're thinking, well, how does that help me? Well, go ahead and sketch it out, right? Because you have 30 degrees, imagine, and another 30 degrees. These are all central angles. And I think it's going to be a little tricky for me to write in there, but you don't know how many sides it has. So you're thinking, I've got one side, another side, and notice how there's one side for every central angle. And you start feeling frustrated because you don't know how many sides it has. That's the whole point, right? I'm thinking, how many sides does this have? But it's all right, because you can go ahead and just say dot dot dot. I don't know how many sides it has, and we can find out. Here's how. Well, you know that the central angle is 30 degrees. So forgive the handwriting because I'm doing this with a mouse. My slate seems to have not connected. So all these central angles are 30 degrees, right? And you're thinking, how many are there? Well, here's the thing. You can go ahead and say there's n of them, one per side. So there's n of those 30 degrees, and they all have to add up to 360. Well, that just tells you right away that there has to be 12 sides. So all of a sudden we've gone from the key thing that we wanted. We know the central angle is 30 degrees, and now we know that there's 12 sides. And the reason we know that is because all those central angles have to add up to 360. So here's what happens next. The minute that we know that there's 12 sides, well, immediately we know the sum of the measures. That's the next thing. The sum of the measures has to be n minus 2. We learned that in class. So the sum of the interior angles would be 10 triangles worth. Sorry about that. That's the best we can do. So 10 triangles worth, and each triangle has 180 degrees. So now we know the sum of those interior angles. And of course that would be 1800 degrees, but that's all of those interior angles. So then it asks, what's the measure of each interior angle? Well, again, there's 12 interior angles because there's one interior angle for every vertex. There's going to be 12 vertices. So we could divide this by 12 to find out the measure of each interior angle. I'm going to take a little bit of a different approach because I happen to have some special knowledge that we did with you all in class. And the cool thing that we know is that an exterior angle, which I'm just going to show right here, this exterior angle is the same as the central angle in a regular polygon. So all of a sudden I know that an exterior angle is going to be 30 degrees, and since that's going to go ahead and be supplementary to one of these interior angles, the interior angle has got to be 150 degrees. But because I took the time to take my calculator out as well, and I'm thinking, so now we know everything, but just I want to make sure, if I know, and I'll kind of end this problem with this kind of thing, if I know that the sum of the interior angles is 1800 degrees, and I know that there's 12 interior angles, I'm just going to take my calculator, 1800 divided by 12 interior angles. Yeah, of course, it works out. each interior angle is 150 degrees. Well, here's number 4, right? Now this is, again, really similar to 3. We don't know how many sides this thing has. So this is very crazy. We're thinking a regular polygon, but we don't know how many sides it has. But the thing is that you're given some very good information. You're told that the sum of the interior angles is 1440, right? So if you know this sum right there, sum of the interior angles is 1440, well, we have to think about what we know, right? And one thing that we know is that the sides, minus 2, there's going to be that many triangles worth, and we've done that in class. But even though we observed that, sides minus 2, there's going to be that many triangles worth, what does that mean? Well, that's the whole point. That's the sum of the interior angles. Well, this is a little crazy me writing with the mouse. I don't have my slate, but I'm thinking to myself, what does this do for me? Well, certainly I can do the division. You know, we went to 211 and we know how to solve all kinds of cool things. But doing this kind of thing on a calculator is not going to tell me the sides. I'm going to go ahead and just get my calculator fired up, and I'm just going to go ahead and do this calculation real quick. And I'm thinking, oh, what's this going to do? We've got the sum. We can see it right up here. We've got the sum of all the interior angles. I can see that. And the sum of the interior angles has something to do with how many triangles there are. So I'm doing the division right here on my calculator. And lo and behold, I get 8. So what does that mean? It has 8 sides? Of course not, because that's n minus 2. So I've done all this work, and what that is really telling me is that this thing has got 10 sides. So I've done all this work, and I can think to myself, sort of thinking backwards, oh, well, alright, so what we're really saying is that n must be 10. And because I like to think a little bit forwards and backwards, what are we really saying? If there's 10 sides, and this is why I like to do it this way, if you knew that it had 10 sides, you'd for sure be saying that there were 8 triangles worth. And if there were 8 triangles worth, the sum would be 1440. So forward and backwards, that's really the point of everything we've done. I know that this thing's a decagon, and we've had a lot of fun with this, but hey, at the end of the day, we're talking about a decagon. Oops, that was supposed to be yellow. Can I undo that? Ah, there you go, getting better. Hey, we're talking a decagon, 10 sides. Awesome. Why 10 sides? If it has 10 sides, it would have 8 triangles worth. If it had 8 triangles worth, the sum would be 1440. We're good. Whew. Well, what about an interior angle now? Well, from this point, everything is things we've already done. I'll go ahead and do it with you because I'm here and we've got the time. So let's go for it. 10 sides, huh? Well, we don't have to draw the whole thing. That's the point, right? We don't have to draw the whole thing, but we could say to ourselves, one side, two sides, one side, two sides, 3 sides, 4 sides. I'm not going to draw the whole thing, but there's 10 sides, so there's 10 interior angles, and by this time we're just saying everything that we've already done in the past week. If there's 10 interior angles, one for each vertex, one for each side, and they all add up to 1440, well then I suppose each interior angle must be 144. Nice work. This is getting a little bit tough writing with this mouse, but hey, let's hang in there. Nice job. So now we've got an interior angle. Whoa, very obtuse. 144. Fantastic. But what else did we have to do? Let's see. We've got each interior angle. Nice work. Each exterior angle. Well, a couple things. If you know the interior angle is 144 and you know that these exterior angles are supplementary, right? So all of a sudden we have the exterior angle as being, um, I'm just going to do it in my mind, I'm thinking 36 degrees for those exterior angles. All right, so, so now we have the exterior angle supplementary to the interior angle. That's 36 degrees. But the interesting thing is I'm thinking about the central angle. And by the way, even though I didn't draw all the sides, so you're thinking, gosh, I'd like to draw the whole thing. No matter. You know that this thing has got a center. It is a nice regular polygon. You know that you've got these central angles. I'm just thinking to myself, because I can't see the top of the screen, does it ask about the central angles? P.S. They're going to be 36 degrees, but let's just take a look. Oh, sure. A little messy, but hey, listen, we're almost done. What's the measure of a central angle? A couple ways of thinking about it. I know that the central angle is the same as exterior angle, so this has got to be the central angle. Fantastic. Has to be 36 degrees. But there's another way of thinking about it that I just want to end with this. Here's another reason why you know it's 36 degrees, and this kind of ties us into number 3 that we had done before. Here's the thing, right? One central angle, two central angles, three central angles, four central angles, five, six. Well, come on, he didn't even draw them all. But you know what? There's 10 of them, one for every side. So 10 central angles, and here's the punchline because I want to kind of end with this. 10 central angles, what do they all add up to? Really? They add up to 360 degrees. So all of a sudden we know what each central angle is. 36 degrees, exactly the same as an exterior angle. So that's kind of the summary of everything we've done in the past week. We know a lot about central angles. We know about interior angles, the sum of the interior angles, exterior angles. It's quite a bit for something as, people think it's basic, but hey, regular polygons, awesome. All right, thanks. Take care.